What's up, guys? Welcome back to the channel. This is probably to the absolute extreme, but I woke up the other day. I was like, it's time we build our own frame. After messing with this thing, being discouraged with it and how rough it was and how beat up it was, and just to get it back to this point, the hours and hours of work we put into it, I was like, it's time we build our own frame. So I've got a 250R frame that's all sandblasted. Now, this one actually came with me from New York. Notice the pivot bolts were all egged out. Everything was dented up. This frame has been used and abused. It's honestly a pile of crap. So this is going to be a great template for me. So I already went ahead. I started putting dots on here. We're going to get this thing 3D scanned. And guys, I'm going to build my dream quad. It's going to be half billet, half fabricated. It's a removable subframe, all kinds of fun stuff. Now this is a completely side ADD, like total side project from this guy right here. So we're going to continue on with this. So you guys are going to see weekly updates with this build. Later this week, we're going to have a video talking about the swing arm. We just got this all finished up and powder coated. We're actually going to start assembly on this bad boy. But in the meantime, I'm going to do a deep dive because a lot of you guys have been talking about, I want to see CAD, I want to see drawing, I want to see how you guys actually draw your parts. We're going to do a deep dive on this frame and how I guess I'm going to draw a frame. So you guys are going to follow along with me. I'm going to draw my first ATV frame in CAD, and it's going to be sweet. So let's start with 3D scanning. Let's jump into it. Now, instead of boring you guys and having you watch me put dots on a frame for a couple of hours, I already went ahead and I actually put all the positioning targets on the frame. Now what this does is it actually allows the 3D scanner to pick up on them. So it actually saves the coordinates, and as I'm walking around the frame with the scanner, it basically keeps it in the computer. So I am going to get the scanner out though, and I'm going to show you guys exactly how this works. Now this scanner is made by Peel 3D. It's something we purchased a couple years ago with the hopes to actually build a frame. So basically, as I'm scanning, we've got light going onto the frame, and it's recording the texture, it's recording the positioning targets. If you want to walk over to the screen and show them, you guys can see on the screen right here what it's doing. Pretty wild technology. I saw these scanners a couple years ago, and I had to get one. They're not cheap. We bought the one that does bigger parts like a frame, and we actually purchased one for doing scans like engine cases and anything that's a tighter tolerance. I already did most of the work off camera, so you guys didn't have to be super bored with watching me do this. So the next step is I'm going to email this file over to my computer, and when I get home, we're going to hop on the laptop and I'm going to show you guys how to take a scan and start drawing on it. So let's go to the next clip. Guys, I've been using Fusion since it honestly came out. It's been a hell of a learning curve the last like 6 to 7 years. Now, I've drawn hundreds and hundreds of parts in Fusion, stuff that's pretty large, such as trailing arms on a Honda Talon, and basically doing our big wheel swing arms. I mean, that was a heck of a task when we took those on. If you don't follow our big wheel channel, you can definitely check that stuff out. But yeah, we're gonna draw an ATV frame. So this is gonna be pretty wild. So the first step, guys, when you get your mesh into Fusion is actually aligning it. So it's gonna come in there. It's not gonna have really any orientation. So I'm actually gonna fine tune this thing and get it 100% square in the software. So when I go to draw it, it's actually perfect. Now, it's not easy to do with a scan because, again, it's not aligned properly. So you're going to see me kind of fighting with it and just doing some tweaks. And yeah, so my idea is to actually start with the pivot bolt. I think that's going to be a great starting point for centering the frame up. So right here, I'm basically just drawing an imaginary pivot bolt. I'm going to get the frame actually completely centered so you guys can see the origin is completely centered on that bolt. Now, more or less, I'm getting a known distance from end to end of the frame, and then we're going to drag the frame left and right on that imaginary pivot bolt. And right here, you can see I'm adding some sketches in there. So when you add a sketch into Fusion, you can actually rotate your part on that. So I'm going to select the frame, and I'm selecting the sketch, and this is going to be in degrees, and this is going to allow me to actually rotate the frame around that known origin point. Now bear with me as I make this video. I'm really good at running this program. It's probably the first time I've actually tried to I guess show it off or teach it in a video, so we're gonna learn this stuff together, guys. And yeah, if you have any questions about Fusion or you're getting into this trade, definitely comment and let me know. Feel free to send me an email. I'm always willing to help with this stuff. It's honestly why I'm doing what I do, because I enjoy drawing parts. Some of this stuff is going to be in fast forward because all I'm doing is I'm just tweaking it. So right here again, I'm just selecting, I put axis 1, axis 2. You can kind of see how I'm still lining this thing up. So it takes me quite a while to line this up. I'm basically rewatching the footage that I took as I was drawing this frame, and I'm doing a voiceover for you guys just explaining what I did. It would be too hard to do this on the fly. Maybe in the future videos we will, but yeah. Anyway, guys, so right here we're still doing some alignment. So I'm moving the frame left and right, and yeah, we're getting it aligned to that origin. Alright, so now for the more exciting part of this process. It's time to start drawing some frame pieces. So right here, guys, I'm basically just sketching out circles, lines, and squares, and we're getting some stuff kind of roughed in. So right here, I'm playing around with the foot peg offset, and we've got the pivot point for the brake pedal. I'm probably honestly going to machine a stainless insert that threads into the frame. I don't think I want to go with the original design on that. It's just kind of a pain in the butt to machine that. It actually makes the piece longer than it has to be. Now, when we build this frame, the number one thing that is crossing my mind is I want to have replaceable parts. I want absolutely every piece of this to be replaceable, right down to A-arm tabs, pivot points, stainless inserts, and I should mention we're going with aluminum on the chassis. So we may go similar to like the Yamaha YFZ450R, and if you guys don't know, I mean, look that up. Yamaha's been doing bolt together frames for years. They're honestly one of the best designs ever done in the ATV industry. I think having a 250R geometry frame that's bolt together, it's going to be awesome. The number one thing that is great about the bolted frame is they generally do not crack. It allows just enough flex on all the bolted components to make that thing super reliable. And again, all the pieces are going to be replaceable, from the sides of the frame to the pivot area and the subframe. And you guys will kind of see as we build this how it's going to end up. It's hard to really explain it till I show you, because honestly, guys, I'm just pulling this thing out of my head right now as I draw it. I'm going off of the mesh, but I'm also going over hundreds of variables in my head. I'm going, how do I want to do this? How do I want this thing to actually bolt together? And I'm just thinking of every angle that I can as I'm drawing. And I'm going to make a lot of tweaks through this process. There's probably going to be a couple of prototype designs that are going to be machined and put together. But that's all the fun in making parts. It's why we're doing it. Now, it's not easy to get this to work how you want always. It can be a little bit of a challenge. So sometimes you end up with pieces that don't look quite right, and you just kind of tweak it from there. So right here you can see I'm working on the angle of the upper frame tube. And this is basically going to go from the lower foot peg all the way up to the top shock mount. And there's going to be a center spline going across that's going to attach to the upper shock mount. And what this is going to allow us to do is we're actually going to be able to have different center spines. If we want to go to a no-link setup with maybe an 18.5-inch shock or just an OEM shock mounting point, we can swap the center sections of the frame. So my goal is to be able to swap setups throughout the frame. Maybe I want to run a no-link for a while. Maybe I want to go back to a stock linkage. Maybe I want to run a CRF link. It really just depends what I want to do. I was a big fan of the CR500 link frames. And if you guys have seen all the trike builds that we've done a lot of conversions with the modern trike chassis where we were actually running the modern CRF shock and linkage, and that thing handles unbelievable. And I would like to eventually bring that into the quad chassis. But yeah, guys, for right now, we're just kind of going for it. It's probably gonna look a little weird to you at the beginning. If you're not into watching this stuff, you can definitely fast forward and see what I came up with at the end of the video. But I absolutely just love pulling something out of my head and trying to make it work. So right here, I'm kind of just moving it around. You're gonna see me honestly moving this frame around hundreds of times throughout this video here. And this isn't fast forward, so we've got the video actually going 4 times faster than what I was doing in real life, because I actually have to sit there again and just really think about what we're gonna do. So right here, I'm coming up with where is the bolted subframe gonna go. I kind of just chose that position for now. I think that's gonna work out. Again, we're gonna draw everything in the end before it gets cut and machined. But that's a really good starting point. So we're gonna go with that. We're gonna press pull back. And again, all this stuff is gonna get tweaked as we go. We're gonna add shape to it. Right now it's kind of just roughed in. So like right there, you can see how I'm press pulling. And there's hundreds of ways to do this in Fusion. I'm just doing it the quickest way possible that I know for the video. But yeah, that's starting to look really good. I'm happy with it. So now that we have the shape kind of roughed out, I'm actually going to start adjusting the curves. I'm also going to adjust the thickness. Right here, I'm just sketching a straight line from top to bottom. I want to make sure we keep this thing so that when we go to machine it, it's still a nice rectangle. Now, this is going to be bolted together. Like I was saying earlier, it's going to be partially welded and partially bolted. So we're going to have a welded section in the front that's going to have rails that come back and bolt to the midsection around the pivot point and the shock mounting points. So this is going to bolt on the top and bottom. I'm just kind of playing with the alignment because I do want to keep everything kind of similar as close as possible to the shape of the OEM frame. However, we're going to modify it so it's our design. Now, there is a bunch of weak spots on the TRX250R frame that I would like to address while we make this frame. So that's one other thing I'm kind of thinking of. Now, cool little feature on Fusion, you can actually go on McMaster-Carr and import your hardware. So we're going to end up using some nice zinc-plated hardware, but for this sake of this video, we're just going to put the black oxide bolts on there. So more or less, you orient your bolt, you can tell it where to go with an alignment. Flip it, make sure it's good. This is just so I can get a rough idea of what I'm looking at. We're going to use a series of dowel pins and hardware to actually put the 2 frame halves together. It's going to be very similar to what we've learned on our big wheel swing arms. That was a huge task for us, just taking a welded component that had over 40 pieces and getting it down to 7. Of course, you've also got the hardware, but it's the same kind of concept with an ATV frame. So there's honestly zero money in making frames. It's more you do it because you love it. Now, for me to ever streamline possibly producing these for guys that want to have a frame for racing motocross or just a restoration project, this stuff has to be machined on a CNC machine as much as possible. So all my components such as A-arm pivots, weld nuts, steering stem, bearing holder, all the brackets and mounts are actually going to be made on our CNC machines and then welded to the tube frame. It's the only way you can really streamline this stuff. Hand making this stuff is just not going to work in today's day and age. It's already hard enough to keep everybody happy with lead times. I mean, it's not uncommon to hear of builders in the industry taking a couple of years to actually build and produce frames. There have been some guys that have done it faster over the years, but if you guys want quality, it unfortunately takes time. Now, the only way we can kind of mesh the 2 worlds together from quality to speed Generally when you get something quick, it's not quality, and generally when you get something quality, it does take a while. And the only way we can mesh that together is actually going with CNC robots to make these components. Of course, there's still going to be human interaction. There's going to be welding. There's going to be fitment. There's going to be assembly. There's going to possibly be coatings. Yeah, you're going with an aluminum frame, but you're probably going to end up having it either powder coated or anodized. And guys, that's just stuff that takes time. So just keep that in mind when you're thinking about possibly getting a frame in the future from anybody. I mean, just this is quite the component. So it's something I'm keeping in mind. I'm not going to put a lot of pressure on myself, but I do want to see this thing happen in the next couple of months. It's been on my radar for pretty much my whole life. I'm going on 37 years old here, and this is kind of a life dream to be actually making my own 250R chassis and producing it in-house. Yeah, it's just one of those lifelong goals that we're finally going to pursue, and I hope you guys are as excited about it as I am, because I feel like the industry is kind of boring right now. Everything's kind of been done the same for years. It's time to bring modern technology into the 250R and kind of bring it up to today's standards. Now, the cool thing about this frame is we're actually going to make this so it fits the Sierra 500 motor. It's also going to fit the 250R, of course. That's why we're doing it. And possibly maybe a modern 300 two-stroke from Beta, KTM, Husky, Gas, all those fun ones. So the goal here is to have a very universal chassis that is 250R geometry, but at the same time, it's going to allow us to swap power plants out without actually changing the whole chassis out. So we should be able to swap motor mounts, swap frame tubes, and do this without actually tearing the whole bike down to nothing. I don't know if you guys are familiar with possibly the JRD chassis. I've had about 4 of them. So back in the day, if you look up JRD, they had a really cool 250R frame that had multiple motor mounts. So it was one frame that would accept either a CRF motor, a 250R motor, or a YZ426 motor. I thought it was the coolest damn thing, and I had one when I was about, I'm going to say like 19 or 20 years old, and yeah, I loved it. It was cool. The only problem was I couldn't keep the thing together. So there's a lot of tweaks that have to be made to make something reliable. So right here, guys, I know I'm babbling on about all my thoughts and ideas, but that's really the point of this video, and I'm actually looking for you guys to hit me up with some feedback in the comments, the emails. Hit me up at bvcracing@gmail.com. You can also go to bvcoffroad.com and use the contact us page, and of course the comments. But any of you guys that have ideas, if you've had an idea in the back of your head for 250R parts or anything that you think should be made, hit me up, because I kind of want to go all in on the 250R stuff. It's just something I've been doing for years. Oh, what's this, guys? Oh, look at that, a Billet A-arm. So I haven't told anybody, but I already went ahead and started drawing my A-arms. These are going to be +3, +1. And yeah, they're going to be 3-piece design. We're going to run either ball joints or uniballs. This is the ball joint design A-arm. It's pretty sick. Now it's going to be the max ground clearance design. I know this is going way off into another talk, but I had to just pull it in here and show you guys what we have been working on behind the scenes. And again, these things are all replaceable. So being a 3-piece design, you can replace the components if they get dented or damaged. You can do them custom anodized because they are going to be built aluminum. But man, that is a cool looking arm. I cannot wait to actually machine this. So right here, I'm just aligning it. I'm getting it kind of roughed into the frame. It's going to be final aligned once we get the rest of the frame drawn up. But yeah, that is looking really cool. Alright guys, so more or less just trying to come up with a design that is safe. Number one, it's not going to come apart. I had to do some creative thinking, so I did step away from this bad boy for a couple hours. I was already a good 3 hours into drawing the rest of it. And again, everything is kind of just roughed in at this point. So my main idea here was to have a hidden bolt that goes behind the frame tab. Now that piece you're looking at right there is actually going to get welded to a frame tube, so it's basically a slug sticking out the front. Again, very similar to the Yamaha YFZ450R design. However, this one actually is going to have a hidden bolt behind. So once that top frame bracket is bolted over the center spline mounting hardware, it's basically locking that bolt in. It could never back out, which is pretty cool. And again, those frame tubes are going to be welded together so they can't spread. It's more or less just a little safety feature that I'm kind of working on. Now, I decided to go with square tubing because it's going to actually help me design this frame. It gives me flat planes to work off of, so we may possibly go to the round tubing on the final design, but for just drawing purposes, we're going to do some of this with the square tubing. So just keep that in mind when you're watching the video. And I quickly drew up a little front section that's made out of billet too. And like I was saying, for speed, we've got to make all the mounting points and all the brackets have to be done on a CNC machine just for accuracy, templating, and speed. Now, if you don't know what you're looking at, this is a CR500 motor. So more or less, again, I want to make this thing fit a 500, a 300, possibly a 450, but the goal here is to go with the 2 strokes. Now to make this work, I actually had to drop the frame tubes down about 3/4 of an inch. So right here with the stock frame, with the pivot bolt aligned and the motor sitting at the correct angle, it just does not fit. So right here, again, we dropped the tubes down about 3/4 of an inch, which is actually less than I imagined it being. I may go another 1/4 inch, but I'm not 100% sure yet. I'm going to play around with this design and, again, possibly make tweaks. So this is 100%. We're just starting out. We're just kind of roughing it in and more or less daydreaming at this moment. And I keep going back to these A-arms. I think I'm more excited for the A-arms than the rest of it. Reason being is if you're going to order A-arms that are of quality in this industry, it does take quite a few months to get them. So it's quicker for me to just go ahead and design them, prototype them, cut them out, and just build them myself. Super pumped on these. I can do different lengths, I can do different offsets, may change up the spindle design. I'm planning on running all TRX250R spindle caliper and hub, and same thing with the axle in the rear.
All right, guys, thanks for watching. In the next video, we're going to take an even deeper dive and we're going to start finishing up the front half of the frame, but I think we've got a great start in this video. And again, this is just kind of like side content because a lot of you guys are like, hey, I want more 250R content. So this is probably going to end up being like 20 to 30 videos. So stay tuned for a bunch of content on us actually making this come to life. And don't miss out on the next video of this bad boy. Let's not forget, this thing is going to be going together. We're going to start assembling the next few days and follow up with a video on that. So we'll see you guys in the next one. And thanks for watching.